No, it's recording. Yeah, I received a message. So now I am working on the University of Stuttgart as a postdoc and in topics related with knowledge graph and representing information in knowledge graphs. And today I'm going to show you how to use a knowledge graph with this platform, but there are many platforms, but we choose this because it's easy to install. And I assume that some of you have installed this in the meantime. And so I am going to show you how to use this with some data. So for this, I'm using, let me share with you the screen. Let me see how this share screen. This is the browser. So now you can see my browser.
Yep, we can. So everyone, this is GraphDB. Did anyone of the workshop participants didn't install it yet, doesn't have it in their computer? If you have problems, please just unmute yourself, say, or type on Slack, so we will all be on the same page. Is it?
Yeah.
Does everyone has GraphDB at the moment? If not, please let us know so you can follow the tutorial.
Yeah. So when you start with GraphDB, you install it, then you go to this URL that is marked here, that is have this number that is the port that is locally, but you can also, of course, install this on a remote machine and then prepare this with your own URL. But when you have this locally, you have to access this address, but this is automatically done when you start the GraphDB. And then the first thing that you have to do is to go to setup. Then you go to repositories. Here I am running these 3 repositories. So I created one that is BOM. So when you create a new repository, you have to go here. Then there are 3 options to create repository. One is the GraphDB free. That is because I am using GraphDB free because there are 2 other versions that are the enterprise version and the other version that I don't remember the name. And you can also create a repository with these other 2 options. But the second one means to run graphs over a relational database, as Stephen suggested in some moment. That means that you have a relational database and then you can see this database as a graph. And the other version means integrating several knowledge graphs into one. Yes, but here we are going to just start with a local graph. So when you create a new graph, you have to provide a name. So I have created this, one of them with a demo, but I want to create demo 2. And then this is just a demo. This is a description. And then you can, you can use reasoning. You have to define the rule set. So if you don't want inference or reasoning, then you can say no inference. But here, so typically when you have big data, then you don't want too much complex reasoning. So we have different profiles, and RDFS is probably the simple one. Then you can go for RDF-L, and there are others that are more complicated. And this is defined for queries, and this is probably the most complicated. But our data is small, so it doesn't matter as much if which of them you use. So you can go for the more complex one, but just for this example, if you have more data, you have to go for a simple profile. And then you can use validation of Jekyll, but we are not going to use Jekyll in this example. And then you can choose this because the database is small. And this is to set timeouts. When you run this query in the web and other people is going to access your data, then you put timeouts so they don't get down your server. So we are done. I want to create the repository. And now I have this new repository I recently created. And this is it's starting now. But I am not using this. So I have 4 repositories running, and I am using this one. So to change from one repository to the other, I have to change this on this corner, the top right corner, to change the repository. And I cannot see because it's screen. Yeah, now I can switch to POM demo 2. And now that I am inside, I can show you that this repository is empty. So if I go to graph overview, I have a default graph because you are always using, you can have different graphs in the same repository. So I have this graph that have no name, and then this have no data. Yes. So to start putting the data inside, so I created this data for you. See. So I created this data that is mainly a data that was created from BORN. And so I added this. I'm going to share this link with you using the chat. The chat is not the chat is here. So now you have the link in the chat. And this is the data I have used. So you have to go for the download this data in the raw way, not with all this, the HTML, and then have this data before. So
please, workshop participants, follow, because probably you will need it during the workshop. So who is participating, go to the link, download the graph
yes,
that Daniel just showed, and let's explore it together. If something is not working, just unmute yourself and let us know what the problem is.
yeah. So now we can import this data. So you can go to import, and now we have 2 ways to import data. One is the tabular, so this means that you are going to import a CSV or a table from a relational database, but this is not the case because we have RDF prepared. So here we have 3 ways to import. So I can add here the URL, but I have downloaded this data, so I'm going to upload the data. And to upload the data, I have to press import here. And the options that they have are enough to import, so I'm going to press import. Now it's importing. Have to wait. Now it is imported. So we can go to explore again, graph overview. We go to, and now we have triples inside. Yes. So this is the format that data have. So this is the subject, the predicate, the object, and then we have this context that is the name graph, but this is the context of the data. So, but when I selected this option, they give me this default option. Yes. Now we can use the interface to visualize your data, to have some information about it. For instance, we can get the class hierarchy. This means what are the objects in the data, and the most relevant class, or the bigger class, is this. Is the one that includes all the things that is is covering my. I can please click on them. I cannot click on the outside. This covers all of them, but I can click this, and this is BORN-based object interface. Yes, and this is the properties. These are the instances that this class have. We have 17 instances, and I can look on each of these instances. Yes. Then you have a class that is this is the class room. No, elements. Yeah, this is room. This is the central room that appears 2 times. So the smaller classes are the classes that inherit from other classes. Yes. So we are going to check how many rooms there are. In this case, in this data, there are 2 rooms. So I introduced 2 rooms. Yes. This was this data was produced using BOM, but I just changed the long git that was at the end of the URIs to get more readable for the exercise. So I'm going to just copy one of these links to the clipboard to visualize the graph for some of these rooms. So if we start with this room, then we have this information. So this is a room. This is the first room. And this room belongs, this have an arrow that is the type. So this is a room. And also is a name individual. And it has, the room is defined by a perimeter. Yes. And this perimeter is, you can expand this information about the perimeter here. So now we got that the perimeter is of type polyline, and this have a property that is the BOM geometry polyline control points. You can notice that this is the name of the attributes in the BOM software, but now is the level of an edge. So we are representing the objects in BOM with the nodes on this graph. Now we can go to this node that this is a control point to expand this one. And then we can see that this node represents a control point list. So this is a list of control points, and this has include 4 points. This is the point 0, 1, 2, and 3. Yes, so we have these 4 points. And if we go for one of these, this is, you can say that this point is a point, and the data of this point can be seen here. So it have 3 properties that are point control geometry point X, Y, and Z. So this is the structure of the point.
Just to let everyone know, as you see, this is exactly the information that we created in Grasshopper this morning. So it's exactly the one that we have in Grasshopper. We import it in GraphDB and we can see this information. And similarly, we can take the results from here and import it in Grasshopper, and we would have the object of room, because this is the room. It has some control points as a location. So the information is directly the one that we modeled in Rhino Grasshopper.
Yes, so we can also have this.
Which format do we use for importing back in Grasshopper?
The turtle, TTL, the one but that was not perfectly working right now. But we have the example files in GitHub that Alessio showed today. You have the way how you can convert from BOM objects to a graph, and then you have from turtle, from TTL to BOM again. And Daniel, there is a question. Can you repeat the visual graph action? Ibrahim Nazim, could you, I guess probably you didn't copy the URI, the link, but can you unmute yourself and say what the problem is?
So I can visualize the graph yet. I can see the class relationships and the class hierarchy stuff. When I go to visual graph, there's a bunch of options. So easy graph, advanced graph configurations.
So you cannot repeat that I am doing, or you cannot visualize that I am projecting?
Yeah, I can't see what you are seeing.
Yeah, but you don't get the same graph.
I don't see any graph. I think I need to.
But when you started, for instance, let me go back. So if some of you haven't seen that, so when I go to visualize, back. So at this point,
yes, that's what. Yeah.
In this point, I have to put the URL.
Okay.
So in this case, I started with this URL that I have copied from the data. Now I can start with the initial data, and then I can continue expanding the information.
From where do you take that URI?
Oh, I take the URL because
it is on the data.
You remember that there was
So,
on the data, and then I have the data here, all the data, but I just was in the class hierarchy, and in the class hierarchy, I inspected what if I click on one of these classes, for instance, this class, I can see all the instances on the class elements room. And if I click one of them, so I click at this one, but I can click the other one for room 2. So I copy the URL to the clipboard.
Okay.
So then I copy the URL. I have to move this down.
Okay.
Yeah, I have this window on. So
I missed that step before. Okay, got it now.
Yeah, now you can see.
Yeah. Now I got it. Yeah.
I am trying to move the window. Now I can see. Yeah. Copy the clipboard. Now I copy this, then I move to this one, then copy this one here. Then I generate now the data from the other relationship, and I started navigating the graph from this node.
So that URI is the ID for the specific node, right?
Yeah, the URL. So every node consists on one URL, and this URL is attached with some information, but only using these edges between the nodes.
Okay.
So this data represent that Stephen mentioned it, that is a triple in the sense that you have the subject, the predicate, and the object, and then you can expand this data. So these nodes are, all of them are URLs, but they are some information that is not URLs, and this is mostly with literals. It means that a number or a string that is a property of the data. Yeah.
Okay, got it.
Yeah. So you can also see this other interface. This interface shows you relations between different classes and the links they have. For instance, I have this room, and this room have a relationship with a related class, and this is geometric polyline. So this means that a room has a geometric polyline. Yes, and then you can go to the room, but here is the room, and so this is the relation between the room and the geometric polyline. That is elements in the room. Yes, so you can use this also to go. I think that they have to explore the data. I click it twice. I just some. Yeah. So this is the visual graph. They have another functionalities, but here I cannot show this one because this means when you have objects that are similar, then you can show these similarities between different objects. But this implies creating an index of similarity. Yeah, but so now I'm going to, when you start with a SPARQL, yeah, to create the queries in the SPARQL, this allows you to ask some quite flexible different queries. So queries are in several forms, but they typically go this. So you have construct queries, select query. This is a select queries, and you have also ask queries, and you have another kind of query that is called describe. And then you can also run queries to update your data or to run some question over the data. But we are going to focus on select queries. And in this case, the select query has some first the select part. Then you have some variables here, but here I just write a wildcard that means any variable. And then you have a where part that is after the select part. Then you have a pattern. And then you have some modifiers, and this case is the limit. So I'm going to write just modifier 10 or modifier 3. So I'm going to ask for some data from the graph. So I'm going to run this query. You can run the query here. Let's see this. Clicking here. I cannot click at this moment. Let me see what is happening. Why I cannot click? Now I can click. I don't know why. For a while I was not able to click. The hand doesn't appear. But now this produces these results in the query. There was RDF type, RDF type, RDF type. Not so much interesting. So the idea is that if you want something here, for instance, just the subject, or just a subject, or I want to create this one. So RDF type, yes, this automatically created a prefix here from this query. So I want to see what elements belong to each class. So this is the class, and this is the element. So I have an element, for instance, this is of this type. So I want to run this. Now I have that this type is of type property. This is inferred for the data. So now this data is not getting so much interesting because this information is from the ontology. Yes. So I don't want to. So this is showing some data that is not from the data I have. It's from the ontology I am using. So I'm going to turn off the inference here to get data from the actual data I have uploaded. So I'm going to run the query again. And now you can see that you have an element that is this bomb, or this is the ontology. You have the description of the ontology, the title of the ontology. I'm going to add some additional data. And then we can have that we have an element that is today, and this is belong to this old class. They are classes. So let's continue with some additional query. So this query is like the previous one, and this query is so in this query I want to see every element that belongs to a room. Yes. So I have this variable. So this is the element room. So I'm just to make this more easy to read. Yes. And then I want to see what elements are part of the rooms. I want to run the query. And I have two elements of the room. Yes. So these are the rooms I have previously shown. So now I'm going to show you what is the intuition with this query. And to see that, I'm going to share my new share. This is let's see. This is turned off. Yeah. So now you can see this as a white page.
Yes, we can.
Yeah, excellent. So in the graph we have something that is it's like this. So you have a room that is the room 1, and the room is of type room. Yes, it's have a long name, but it's the URL, and then you have another room 2. It's also of type of the room type, and also you have a third room is room 3, and this you have this data, and you also have type here. So, and the query that I have written in the other page have this is a query that have this form. You can see the other page at the same time, or you continue seeing the previous one? You can see the other
We see
window?
the remarkable.
Yeah, so you see the same. Let me check. Sure. Now you see the other?
Yeah.
Yeah. So you can see here that you have the room now is a variable, and now you have some. This is A, but the A is just a wildcard for this type. It's just a abbreviation for this particular this is a URL but this is expressed in a compact way. So these prefixes here means that this URL that is long here have to be written as the concatenation of this with this. So this is the same that if I were writing type here and then copy this one here. This is the same. Yes. But to be short, we typically write just type RDF type, or even shorter, we just type a because this is used in many places. So that we have here in between this parenthesis and this parenthesis represent a graph. So if we go to the other this one. So in your imagination, you can imagine that your new graph is something that is room. It looks like this. This have a type, and this points to a room. Yes. So this is here is the query, and here is the data. So the idea of the solutions from a query and a data is to find a match. Well, this is a match between the variable and an element that also match this one and this match this three. So this type match the type because they are the same constant, this and this. This room makes this room because are the same constant, and this variable make the match with this URL here. So now the output of this is you can consider the variable that is room, and the output is the match that means R1, and sorry, is R3. This is one answer, but you have three matches because you can also match the other triple here in the same way. So you finally end with the three values in the answer. Okay, so you have this as the answer. So this is the intuition we have in SPARQL, but you can define different queries based on this intuition, and there are other operators. So now we are going to show another query using this intuition. So now,
sorry, I don't get any results from that query that you just wrote. I'm wondering, maybe I have a different rule set applied to this. Can I ask what rule set did you set to the repo?
Yes, but I'm not using, I can turn off the rule set, and if I run, I still get the answer. So this is this is not related with the rule set. Probably you don't have you have a difference between in the queries. So I'm going to copy the query. I'm going to put in the chat. Can you try with this query? I just write in the query in the chat.
I will try.
Just copy the query on the query form. And
yeah, yes, now it works.
Now it works.
I must have done a typo somewhere. Thanks.
Yeah, I think so. Yeah, but so this query looks for the same. Yeah, this I have run this query. So this query, it looks for rooms. So it's something that is a room. Next query is something that here I have a particular room, but this was the room that I have used before. So I want to fix this one. So now we have a room, and when I put a wildcard, this means all variables that are in the query. Yeah, so this is the same that writing here this. So I want here the properties of this room and the values. So this is the property and the values for this particular room. And I'm going to run this query. And then you can see that we have many answers. I want to turn off the inference to just the query on the answer. So this, they have the type that is architecture, elements room, and also have this type that is all named individual. These are two types, and then they have only this property that is the perimeter, and this have an identifier, a global identifier that is this string. So this is literal in the sense that this is not an object, so I cannot click on this and navigate. This is it's like the end of the navigation because it's a literal. But this I can continue navigating on this and copying this, and I can put this on the graph. So these are the properties of this particular instance. And next query is now this query shows that it could be useful to have some inference. So I want to turn off the inference to show the results. So here I am asking for all elements. This is subject, so the subject is here. All elements that belong to the class bond, so to bond object. So I want to run the query, and it's empty because no object is annotated this way, and this is because the rooms are not annotated as a bond object, but the class bond object is a subclass of, so the class room is a subclass of bond object. So if we turn on the inference and run this query again, then we can see that the three rooms are actually bond objects. Yes.
How is everyone doing? Is anyone following the tutorial from the workshop participants? Is there anyone who has a question on how to follow? Or are you familiar with querying information with any other querying language? Because SPARQL querying is also super complex, but it just works to see how it works. And then if you want to apply something during the workshop, we can still support.
Yeah, we can try.
Yeah,
we can try it. So if you have some question or if you want to have again the same intuition, but so I think that probably the SPARQL have many details. So the idea is to have some intuition that here we are putting a graph with some variables, and this is construct against the data. So here I am asking for objects like this X. So this is an object, yes. And this I am asking for objects in the model that belong to the class bond, yes. And since in the model everything is a bond object, I expect these returns of my three rooms, the three rooms that I have created, yes. So this is the expected result, but this is not in the data directly, but is inferred because the class room is a subclass of the class bond object. And this is how inference works. When someone asked Stephen how inference can be implemented, in some cases this data that can be inferenced here can be materialized. In other cases, this can be generated on the fly when you write the query. So there are different approaches. And this can be a bit more complicated with more expressive types of inference, and when the data is too big. But in this case, we don't have so much complicated inference, and we don't have a big database.
Yeah, but whatever you need to query in your own database when we start in group works, you can just try to state the question, how you have it on your mind, and then we can apply the SPARQL query together.
Exactly. We can try to answer this query, or we can try to write your query. And so I'm going to continue with another query. This query shows that every element is, as before, is an object belong to the class bond object, but now I want to see what class they belong directly. I want to run this query, and now I can see that this room belongs to resource, belongs to room, belongs to region, belongs to bond object, belongs to the interface, BOM object and belongs to many other classes. So all of this information is inferred from the data, from the terminological part of the ontology we loaded. And then this class is a particular. So here I'm going to show you the subclass of that we have in the data. So if we turn off inference, then we can see that the BOM object is a subclass. Yeah, so these are the classes where the BOM class directly belongs to with subclass. Yes, so this is directly inclusion of classes. But if we add inference, then we can run this query again, and now we can get that the class of the room belongs to all these other classes because this is inferred from the data. And in this other question, I want to know, this is a property, yes, that I have, and I want to know this property has this relation with this with the classroom. Yeah. And this is written as follows. The property P has as domain the classroom. So what this means? This means I want to share the picture again. This means that you have this is the property, and the property is called this case is a variable. Yes, I write in this P, and we want a variable such that the domain of this variable, so this element here, has to belong, yeah, to a type that is of class room. Yes, so this is the idea on the data.
There is, Daniel, we cannot hear you very well. Can you talk again? Okay, now it's better. The microphone was a bit. Thank you. No, it's still. I think the microphone is a bit far, probably.
To change the channel.
Okay, now it's good. No, it's very good. No, I don't know what the others hear, because for me sometimes it's clean, sometimes there is a lot of noise coming.
Yeah, it's noisy.
It's noisy.
Try again. Yeah, I think it's kind of broken, or maybe you need to reconnect.
To disconnect the microphone.
Yeah.
Oh, it's better.
Yeah, it sounds better. Yeah.
It's a bit low,
low. Yeah.
But we can increase the volume and make sure that we don't talk very loud when.
Now
It's low, but we can hear clean.
Can you try to say a long sentence?
A long sentence. I can. Now you can see the video.
Yeah, it's fine.
It's fine. Yeah. So I'm going to get the computer close to me. So this is because the yeah.
Yeah, sounds fine now. Yep.
It's
Thank
fine
you.
now.
Yep.
Yeah. So in this case, let me see. In this case, we have this element here that I want to write. This is a room. With this room have a property, and this property can be the points, for instance, or the perimeter. And this perimeter is a perimeter. So I want to write a perimeter one. It's the perimeter of this room. So this is on the assertion. And then you have in the schema. And the schema, you have that the perimeter, this perimeter has as domain the classroom. Yes. So this is the domain of the perimeter, and the domain means the place, the entities where the edge starts. This is the domain. So this is the domain, and this is the range. So the domain of this is room. And then in this is the terminological logical part. In the terminological part, you describe the perimeter, and then you describe the domain of the perimeter. So this is the model from the individuals in the data. So that I am asking then in the data is to ask all the properties, the variable whose domain is room. I'm going to back to the data, to the query. Let's see, it's showing. Where is the? I have lost this one. Where is the? I lost the. It's on top. This one. Now you see the GraphDB again. Yes.
Yes.
Yeah. So here we can run this query where it is asking from the property, and the property that requires to have the domain of this class, that is the classroom. So all the properties of this class. So we want to run this query, and then we have the properties in the terminological part, perimeter, control points, and room location. Okay. So this is the information we have in the schema or in the model. And then just to show you some interesting information about this is how they related the subclasses. So this is not a select query, so it doesn't output a table, it output a new graph. So it have a construct query here. So I have this pattern, and it's the same pattern here, but so I am just selecting the information regarding to subclass from the graph. So it just copy this and created this one. Yes. So I'm going to run this query, and I got this graph. Yes. But this is a graph in the sense that you have the subject, predicate, and object. So because it's difficult to see what is happening here, I'm going to go for visual. I go to visual representation of this graph. And now you can see the model of form of the objects that I have using here. So you can see that this is a room, and this no class inherits from room. So this is a base. This is a class. It's not an abstract class. It's just a class. But this is an interface. So this room inherits from this interface, and this interface is a subclass of this other interface, and this is a subclass of this other. So you can see all the structure. So here you have two concrete classes that are point, room, and there are only these two. But we have another here that is sequence in this model. This is control points that is inherits from sequence. So this is the concrete class. Here you have the most general class. Here is probably one object. This is the interface one object, and this is the interface object. This is the most general class because there is no arrows that get out from this one, and you also have the other. This is the. I don't see another class that have this property. Probably this is the most general one. Yes, all the other classes are inherits from this one. Yeah. So now, this shows how you can see the inheritance of any graph you can construct. You can visualize the graph, and this was generated from a particular query. That was different from the first place where you were exploring the data, because then you just put some data, but here you can get some subgraph of the graph, or just creating a new graph you want to create. And the following query I'm going to show you is this query. This query is a bit more complicated. but this extract the point of a room. So the room has the room is a room, so it belongs to this class. So this is the type, and the room has a perimeter. So this semicolon is used to say that the same room now has a perimeter, and the perimeter is this object. So when I put this object is the same, this is a variable that is repeated here to capture the perimeter. And the perimeter now is related to this. This is the arrow that goes from the perimeter to control points, yes, in our graph. So you can remember when we show the graph, we had the room, and the room was connected by this arrow with the perimeter, and the perimeter was connected for this arrow with the control points. So now we have the control points, and for each control point we have some position, because this is a sequencer, so you can go back. I want to show this afterwards. So this is the position in the sequence. This is the point in sequence. And now when I have this point, all these positions that is here. So I am going to filter, because control points have other properties, but I am only interested in the properties that represent positions. And these properties start with this in the position, that is with this underscore. Yes. So this is the URL where position starts. So I am just filtering this P to be a position with this filter. But filter allows you to introduce conditions in the data you have already generated by using this matching. And then at the end, when I have filtered this one position, then I want to recover the values of the position of each point. So this is X, Y, and Z. So I'm going to run this query. And then I got the values here, that is the room, the point, and then I have the 3 coordinates of each point. And I can show you that if I want to order the rooms, then each room this is the room 1. I have 4 points in this room, and they are 1, 2, 3, and this is also, this is strange. It has to be 4. So I think that I missed something in the data. But this is B2, 2, 3, 4. But this is working fine. I have this repeated element here, but they are different points. In the C, it's okay. So I don't know why I have this issue in the data. So I can fix this on the data. I want to fix it right now, but I'm going to fix this later. But so this query, this is a query that gives me the points. So I want to go back to the explore. I want to copy. I want to copy this room. I want to show this one. The room 2. Let's see. Copy. I want to copy this one. Copy the clipboard. I want to explore. I want to go. Copy this one here. Visual graph. To copy here, so you can see the structure. So we have this was the room. They have the room, have the perimeter. That was the level we have navigated before. Then here you have expanded to the geometry, that is control points. And then you have here the points, and we have 4 points, that is B1, B3, this point. So we can see this particular point. And these are the coordinates of the point. So this -1, -1, and 0. So if I go back to the SPARQL query, then I have these results. So an interesting question is how to get the bounding box of each room. So this means that you can have a box that encloses this room. And for this, I created this query. So this query is a bit more complicated, but it's just the same idea. So you have the room, this is the same query that before, but here I group it for each room. I'm grouping the room, and I am getting here the maximum variable that is in maximum position in X and the minimum position in X, and I call them max X and min X. I am doing the same with Y, so this is the max Y and the min Y. And with the set, I do the same. So I have the room, and then I have the result. And the result was that the room has this point, that is the one room is on 2020, and the position was in the first level 0. Another room was in this other area, that was this area, and the position was in level 0 again. And the third room, the last room, was in have the same positions that the previous room, the room 2, but it was in the level 4, in the set position. So my question is, are two rooms overlapping in our model? And the last question answered this one. This is a more complicated question because it's a difficult question to do, but the idea is that to answer this question, I just copy this code that I have written before once and then 2 times. So this is the second time, but I changed the name of room. This is room 1 and this is room 2. And I repeated the same that before, but with this one here, and one here, one here, one here, one here. In every place I added 1, but in the other second I added 2. So because I don't want to have, and then I filter. And this condition is represent the overlapping, assuming that the rooms are square. Yes? Because otherwise the formula is more complicated. But if I assume the room are square, then I can check the overlapping of the rooms with these conditions that you can check. And because I don't want to get the rooms appear twice, because if 2 rooms are overlapping, then I want to have both rooms, both overlaps in both orders. I just added this to select the order between them, to don't have the contrary position between the both rooms. So after running this query, I got this answer. So this means that the room 1 was overlapping with the room 2, but not with the room 3. And this was because they belong to different floors, yeah, different levels of the building. And if you see the coordinates before, then you can see that one room, you can see the coordinates of the rooms. So one room is a square, and you can see that these 2 rooms are overlapping, yes? Because both of them are over the point 0, 0 in the plane, yes. If you want, I can draw the both rooms. Let me show you. Where was I'm looking for my I don't get my new share. But it disappears my check. Yes. So this no, it's here. I was looking the other. Now you can see the drawing again.
Yes, we can see your drawing.
Yeah, so now
that you just deleted.
Yeah, so just was the one room was in this position. This is the room 1, but 0, 2. So this is the 0, 2, 0, 2. And this was in the first level, so it was level 0. And this was the first room. They were the endpoints. The second room was in minus this one, if I am not wrong. So they are overlapping, and this was also in the level 0, because there was the -1, and 1. So they overlap in this area. And the third room was in the same position, but was in level 4. So it was, if I project this one, it was level 4 on top. So this is a projection, isometric projection on top. You understand? This wasn't overlapping, was on top. Yes.
Yep. Actually, this bounding box method is used not only for rooms, it's already used also for some other building elements. And then we just set up a small threshold. For example, you want to check if every door belongs to a wall. It's actually a good technique used like for almost every building element, and we can use it also for the workshop. So instead of having the perfect shape of the building components, we can just use the bounding box of column or of doors or something else. So if someone wants to use it, it's quite useful to check the query that Daniel is introducing. Yep. You can continue, Daniel.
Yeah, but I have finished it with the
queries.
Yeah, with the queries. So
yeah,
I want to know if you have question, if you don't. So in general, when you have, so I imagine that I'm not going to teach you a Spark in some short time, but
yeah,
you can have some intuition of this, and then you can notice that in all these queries you have a graph inside the parentheses, and sometimes you introduce some other operators, like in this case was the filter to get some to select some data or to filter some data out to get just you want.
yeah.
And in some cases you can zoom class aggregation or other operations.
I would ask, could you please save the query somewhere and share with the participants if they need later?
Yes, I want to upload these queries and with the data.
Okay, and then I see that we have a question on the chat from Fatima. Could you please also show generation of knowledge and identification of patterns? Identification of patterns, as far as I can respond, then Daniel, correct me if I'm wrong, it's not so easy to do it with one data set. Like you can realize patterns just like, let's see, this is, in my opinion, in my understanding, this is symbolic AI. And if you want to understand a pattern, you need a lot of data. You cannot understand a pattern from one single house. You need to have many examples of houses, and then you can see that always when this happens, apparently this also happens. It's quite complicated to have some patterns in 3 rooms that we saw. Then the other generation of knowledge, Daniel, you can take over.
Yes, let me I try to remove the chain. Oh, I can unshare. I want to remove the chain. How can I stop sharing? Is pause? No, pause is not. Pause share.
I can also stop if you want.
Yeah, can you stop me?
Okay, I try to share mine. I try to share mine, and it means that I will stop yours. And then I stop, and then I stop sharing.
Yeah.
Wait, I stop sharing, and here we go.
Now
please turn on your camera so we can talk and we can discuss.
So your question was how we can discover patterns. So in general, we try to discover patterns when we have enough data to have these patterns, and there are methods, different methods to discover these patterns. For instance, if you want to, and then when you try with the pattern, you typically want to know how many times this pattern occur in your data. So you need that this pattern occurs many times. This is the support of the pattern, and then you need some confidence on the pattern. So it has to be occur some percentage of the cases. So to discover patterns, typically you have some machine learning techniques or statistical techniques, and this is the discovering of the patterns. And then with the SPARQL, you most of the time do is applying deduction for facts that were already discovered. So there are engines or there are tools that where you apply this tool, this discovers this is a subgraph of this other, or in the case of Jekyll, Jekyll allows you for restrictions. So you can have a big data set and maybe you don't know what restriction you have, and then you want to produce restriction from the data set. And this for that reason, you want to predict these restrictions. And then when you have these restrictions, then you can use them. So this is the idea of prediction of patterns.
I guess that was clear, Fatima, right? Then, yeah. Okay. Do we have any other comment or question? Ashul, I think you are almost asking something, but not asking.
Yeah, actually, I don't have a question. Thank you very much, Daniel. It was really nice. For me, it was an introduction. It's the first time that I'm seeing something like this. I'm not familiar with this SPARQL and something. It was hard for me to follow and implement at the same time. So I just made some print screens for myself and I will try it after the workshop. But thank you very much.
That's
and
great.
Could you please share this final query again via chat or something?
I will share also the recording, but I guess Daniel just said that he will share the full query. And I guess that is actually very useful because, as I said, in architecture, we most of the time to check the logic inferences from geometries, this bounding box method is quite used. I will stop recording at the moment. So until now, we have the lecture recording. We don't have to record every discussion.